there's another way we could find the equation of this same circle, diameter from 2,4 to 10,4. Okay, we can do that by placing a point x, y at an arbitrary position on the circle, and using the theorem from geometry that any triangle inscribed in a circle such that its hypotenuse is a diameter of the circle has to be a right triangle. Now, since the diameter is the hypotenuse of this triangle, the triangle does have to be a right triangle. That means that this segment makes a right angle with this segment. Now, what can we say about segments that make right angles? We can say that their slopes are negative reciprocals. Okay, so for example, the slope of this segment from 2,4 to xy is y minus 4 over x minus 3. The slope of this segment from xy to 10,4 is y minus 4 over x minus 10. Okay, so we have these two slopes, and we know that they have to be negative reciprocals. Okay, so now, since perpendicular lines make negative reciprocal slopes, and the two segments that we had are perpendicular, since they're legs of a right triangle, we write down the slope of the first one, the y minus 4 over x minus 2. I think I said x minus 3 up here because I was misreading it. That's a 2 and not a 3. Okay, y minus 4 over x minus 2 then equals the negative reciprocal of the other slope. Now, that means negative reciprocal of this, which is going to be x minus 10 over y minus 4. So it's negative x minus 10 over y minus 4. If we take that equation, again expressing the fact that the slopes of these two legs are negative reciprocals, here's the equation. If we multiply the equation by the common denominator, x minus 2 times y minus 4, we get, well, y minus 4 times y minus 4 is y minus 4 squared x minus 2 times x minus 10. On this side, we get this equation. If we multiply out the left-hand side, and then, or the right-hand side, I'm sorry, and then add the right-hand side to both sides, the right-hand side becomes 0, and we end up with this term, or these three terms, over on the left-hand side. Now, we see that what we have here is something we can complete the square on. The square on the y minus 4 is already complete, but we don't have a completed square on x squared minus 12x. Since x squared minus 12x plus 20 is not a perfect square. We got it from x minus 10 times x minus 2, so it's certainly not a perfect square. Well, if we complete the square, and I've gone through several details, several examples where we went through the details of completing the square, but we'll go through it here. We're going to add negative 20 to both sides. And we're going to leave a space here because we're going to have to add something in order to complete this square. What do we add? Well, we're going to add 36. We're going to take half of negative 12x, and we're going to have negative 6x, and we square, actually half of the negative 12 that's in front of the x, and square it. We get 36. And we can then verify that x minus 6 quantity squared does give us this. Now, we added 36 here on the left-hand side, so to keep everything in balance, we'd better add 36 on the right-hand side. Negative 20 and 36 is 16. So we end up with x minus 6 squared plus y minus 4 squared equals 16. Now, if you recall, if you want to look back at the notes, this is the equation of the circle that we found earlier by the first method of finding the center and then finding the radius. In this case, we bypassed that. We used this important theorem from geometry that says that a triangle inscribed in a semicircle is a right triangle, and the fact that slopes are negative reciprocals. We put that all together, and we got the same equation, as of course we should if mathematics is to be consistent.